Now for one of Spark's more complex libraries, MLlib. I say complex only because its subject matter, machine learning, is in and of itself complex, which could be a reason behind it having the most maintainers. It might not be the most used library, but it's still very active. The machine learning algorithms it exposes are constantly growing and becoming more and more performant, a number of which are still experimental. But before digging further in, just as we've done in the previous libraries, let's take a look at the competition. On one side, you have MATLAB and R, which have the benefit of being fairly easy to use but aren't scalable. And on the other side are Mahout and GraphLab, which are more scalable but at the cost of ease. Thus, the idea of MLBase was born at AmpLab, driven by the ML stack. This was a three-pronged approach to making machine learning both easy and scalable. The ML Optimizer and MLI were testbeds for machine learning pipelines and algorithm development, where MLlib was the productionized implementation that came out of those testbeds. But Spark's MLlib implementation has subsumed most of this stack, with MLlib being where the original RDD-based algorithms reside, and the ML namespace containing a higher-level pipeline API built on top of data frames, which resembles ideas from the ML Optimizer. These ML pipelines were officially introduced into the Spark package in 1.2 as an attempt to simplify machine learning, embracing machine learning's flow of loading data, extracting features, training the data, and testing that trained data. All through that pipeline, a standard interface allows tuning, testing, and early failure detection. Pretty nice. But what kind of algorithms are in this library? You have classifications, such as naive Bayes, regressions through logistic and linear regression, collaborative filtering via ALS, or alternating least squares, clustering by way of k-means, and dimensional reductions like SVD, or singular value decomposition. And that's just a handful of an ever-growing list. On top of the attempt to simplify these algorithms, many reuse the same data iteratively, so they're able to make use of Spark's caching for some decent performance gains. Then, there's also a number of helpful methods to assist in your feature extraction and transformation, like TF-IDF, or term frequency, inverse document frequency. Yeah, those in the ML field seem to love their acronyms. But how about these algorithms' practical use? What are some of the nuggets of wisdom we can gain from them? There's spam filtering, fraud detection, or even recommendation analysis. Or you can determine the information clusters, even using machine learning for speech recognition. Those, and an abundance of use cases, are at the heart of machine learning. And MLlib is attempting to bring this complex subject matter down to a larger audience than has previously been possible.